Hey everyone, in this video, we're going to be looking at the LeetCode problem, reverse string. Okay, now before getting into this, I'm going to do another quick channel update. So if you just want to skip to the problem, skip to my thought process or the code, you can just go right to that in the timestamps. All right, so some of the older problems that we talked about before, I turned them into blog post. So you can find them here now. So like single number is now a full blog post. It's been fully updated. And then also we have the climbing stairs solution 1 and solution 2. I've updated them a little bit, but I still have to finish up some of the stuff in there. And then all these updated posts are also, you can also find them on the GitHub repo. And also you can now support us by donating on Venmo. All right, so you can find links for all the ways to support us and for the GitHub repo with the solutions to the problems, all the notes and all the code. You can find that in the description below. And then there's also going to be a link for the Discord chat, so you can go there, ask questions, share your solutions, and then be sure to ask questions in the comments below. And you can also find different social media sites that you can find us at. So that'll also be in the description below. All right, so now let's get back to the problem. So we're going to be looking at this problem here called reverse string. So we need to write a function that reverses a string, and the input string is given as an array of characters called S. And here's some examples that were given to us. We have S is equal to hello, where each character is broken up inside of the array. So then the output is going to be this right here, where this H gets switched with that O, and then this E and that L gets switched, and then that L is just left there since there's nothing left to swap it with. And then they give us this other input with S being equal to Hannah, and then these two H's get switched, so then we have the lowercase h in the front and then that uppercase H at the end now, and then the A's will get switched and then the N's will get switched. Okay, and then they also give us some constraints. So they tell us that the length of S has to be greater than or equal to 1 and less than or equal to 10 to the 5th. And then they tell us that S, each, S of I here, each element in our array is a printable ASCII character. And then they tell us that we cannot allocate extra space for another array. So we must do this in place with big O of 1 extra memory. All right, so before going through my thought process, make sure you pause the video and try it yourself. And then you can come back and we can compare our solutions. All right, so I'll give you a second to pause. All right, so now let's get into my thought process. Okay, so first of all, they mention this thing called a printable ASCII character. Okay, so ASCII stands for American Standard Code for Information Exchange, and it consists of 33 non-printable and 95 printable characters. And you can check out the non-printable, printable, and the extended ASCII characters here. There will be a table there, so you can look at all of the characters there. And for this problem, we only care about the printable ASCII characters, so you can go to that link, find the table with all the printable characters if you wanted to check to see what your expected input is. Okay? All right, so then we want to know, what does in place mean, right? So in place refers to an algorithm that transforms input using no auxiliary data structure. Okay, so we cannot allocate extra space for another array, a hash table, or any other data structure. Okay, so another way of saying this is we must use big O of 1 extra memory. Okay? All right, so let me clear this off. All right, so let me make this a little bit bigger. All right. Now, what we're going to want to do is take our two examples from earlier, and we're going to find a way to model the reversing of the characters in S. All right, so we're going to start with the first example. So initially we have S is equal to hello. So we have our H at our index of 0, E at an index of 1, L at an index of 2. We have another L at an index of 3, and then we have O at our index of 4. And then after reversing S, our expected output is going to be this O here that was swapped with that H, and then this L that was swapped with that E, and then we're just going to have that one L there, which is going to be the one unswapped character left. Okay, so to perform this reversal, we need to swap the characters in S, and we can start by swapping the leftmost character with the rightmost character. So that was that H and that O, we swapped them, and then we move to the second leftmost character and the second rightmost character, and then we swap them. So that was that E and that L. And then we're going to continue this process until every character has been swapped, if we have an even number of characters, or until we have one unswapped character left if we have an odd number of characters. So here for this example, we have an odd number of characters, so then we were just left with this one unswapped character, which was this L at our index of 2. Okay, so to perform this swapping, we'll need to loop over S while there are still characters that can be swapped. Okay, so let's visualize this process, which should help us better understand how the swapping is going to occur and to help us better understand what we need to keep track of. Okay, so on the first iteration, we're going to be looking at this H at our index of 0 and the O at an index of 4. So our current leftmost character is H, our current rightmost index, or our current leftmost character is H, our current rightmost character is O, and we can swap the characters by assigning S of 0 to be S of 4. So that's our H and our O there. And we want to assign S of 4 to be S of 0. But before we can do that, we need to first store S of O, or S of 0, in a temp variable. Okay, so storing S of 0 in a temp variable, that's going to allow us to still have the original character that was stored in S of 0, right? Because if you just took S of 0 and assigned it the value of S of 4, then you'd lose that value that was originally stored in S of 0. Okay, so here is the steps for the swapping process. So the first step is we're going to take our temp variable and we're going to assign it that S of 0, and then we're going to take S of 0 and assign it to be S of 4, and then we take S of 4 and we're going to assign it to be our temp variable, okay, which was this S of 0 up there. So after the first swap, what we're going to end up with is our O at our index of 0 and then our H at the index of 4, okay? Now, on the second iteration, what we're going to be looking at is our E at our index of 1, and then our L at our index of 3, and our current leftmost character is E, our current rightmost character is L, and then we can swap the characters by assigning S of 1 to be S of 3, and assigning S of 3 to be S of 1, using that swapping process from before. So here it is, we take our temp variable, assign it to S of 1, take S of 1, we give that a value of S of 3, and then we take S of 3 and we give it the temp variable there. Okay, so after the second swap, then we will have successfully swapped this E and this L. Okay, and at this point there's no unswapped characters left, and our only remaining unswapped character is at S of 2, so that's that L right there. And at this point the reversal is complete, okay, since we ended up with only one remaining unswapped character left. Okay, so to perform these swaps, we had to keep track of the index of our current leftmost character, which we'll denote with I, and the index of our current rightmost character, which we'll denote with J. Okay, so keeping track of the current leftmost index required us to start with I being equal to 0, so we started at the beginning of our array S, and then we had to increment I on each subsequent iteration, so we had to move our current leftmost character, so we wanted to move that in, so we had to increment I so we could access that current leftmost character there. And then keeping track of the current rightmost index required us to start with J being equal to the length of S minus 1, so that would be the end of our array. That's our last index in our array there. And then we had to decrement J on each subsequent iteration, so we could move that current rightmost index, we can move that in to then be able to swap with the current leftmost index. And then we continued this loop while I was less than J. Okay, so clear that, and then we can, now let's take a look at example 2. So initially we have our S being equal to Hannah here, capital H at 0, A at 1, N at our index of 2, another N at our index of 3, another A at our index of 4, and we have H at our index of 5. So after reversing S, our output's going to look like this. So we'd have that lowercase h swapped with that uppercase h, and then these A's are going to be swapped, and then the N's right here are also going to be swapped. Okay, so we're going to swap the characters again like we did in example 1, and then we're going to visualize this process to help us, better see how it happens, right? So in our first iteration, we're going to be looking at this capital H and then the lowercase h, and our current leftmost character is at capital H, current rightmost is the lowercase h. And we're going to swap the characters by assigning S of 0 to be S of 5, and by assigning S of 5 to be S of 0, using that same swapping process we used in the previous example. And then here it is again, we take the temp, assign it to be S of 0, S of 0 gets to be S of 5, and then S of 5 gets to be our temp, which is that S of 0. Okay, and after the first swap, so what we're left with, we have this lowercase h at our index of 0 now, and the uppercase h at our index of 5. So then we'll look at the second iteration. We're looking at this lowercase a and then this uppercase a. So we have our current leftmost character is a, current rightmost character is a, and then we're going to swap S of 1 by assigning it to be S of 4, and then S of 4 to be S of 1, using that same swapping process. Here it is again. And then afterwards, we have this A at our index of 1 is now swapped with this A, the index of 4. And if you wanted to, you could include a check, so an if statement, to see if the characters are the same before swapping, since the result after swapping them is going to be the same. I'm not going to do that in this implementation, but if you wanted to do something like that, you could. Okay. So now let's look at the third iteration here. And for that, we're going to be swapping our current leftmost characters is N at our index of 2 and then N at our index of 3. Okay, so N is our current leftmost character, and then our current rightmost character is also N there. So we can swap the characters by assigning S of 2 to be S of 3 and assigning S of 3 to be S of 2, using that same process again. There it is. And after the third swap, we now have this as our result. And at this point, every character has been swapped, so the reversal is complete. And also notice again that we continued the loop while I was less than j. So if you take a look here, I was equal to 2, and then j was equal to 3. And then at this point, if we would have continued on, if I got incremented again, then I and j would have been the same. So at that point, you'd want to stop it because you've already reversed all of the characters that you can. All right, so using this model that we described above, we can come up with the following implementation. All right, so after going through this, hopefully you can come up with a solution now. And so give it a shot, and then we'll look at my implementation. All right, so now let's get into my implementation. All right, so let me take this and put it over there. All right, so over here we have our function called reverse string, and it's going to take in that array S. All right, so let me scroll up over here to our first example, and we can look at our swapping process. All right, so here what we want to do is we want to have our temp variable, right? So we need to let temp. So create that variable there. And then we also need our indices for our current leftmost character and then for our current rightmost character. So for our current leftmost character, we will let I be equal to 0. So we want to start at the beginning of our array S. And then for the index of our current rightmost index, we want to take, we're going to let that be J, and then we're going to say that's equal to S dot length minus 1. So that will be the last index in our array S. And then we saw from our examples that what we want to do is we want to continue to do the swapping while I is less than j, right? So while I is less than j, we want to continuously do the swapping process, right? So as we move our current leftmost character in and then our current rightmost character in. Well, we're going to do that while the current leftmost index is less than our current rightmost index, because once the current leftmost index is greater than our current rightmost index, then the swapping will have been finished. We will have already swapped all the characters that we can swap. All right, so what we're going to want to do is we're going to look at this swapping process. So we're going to take our temp and then we'll assign that to be our current leftmost character, which will be our s of I. All right, since that starts at the beginning, like however here when we had h at our index of 0. So we took that s of 0, assigned it to be the temp there. And then we're going to take our s of I, which is our current leftmost character, and then we're going to assign that to be our s of j, which is our current rightmost character. So like we did over here in this example, we had our current leftmost character at s of 0, which was h, and then our current rightmost character, which is s of 4, which was o there, right? So now after that, then we take our current rightmost character, and which is s of j, and then we assign that to be our temp. Okay, so just like how we did down here, we took our s of 4, which is o, and we assigned it to be the temp variable, which in this case was s of 0, which would be that h. Okay, so we've reassigned these, so now the characters in this array have been swapped. Okay, so now to move in our current leftmost character, we need to increment I. And then to move in the current rightmost character, we need to decrement j. Okay, so then we can move our current leftmost character, and then we can move our current rightmost character to then be able to swap them on the next iteration of the loop. Okay, so that should be all that we need there. All right, so for our example, we had s is equal to our array with our h, and then we had our e, and then we had our L, and then we had another L, and then we had an O. Okay, so this is our character array S, and then what we're going to want to do is we're going to want to call our reverse string function. We're going to want to pass in S, and then what we can do is we can log our S, because after we put it into this function, it should have, it should update our S character, our S, which is our character array, to now be swapped. Okay, so let's save that and we'll run it. And okay, so that looks good. We got our O, L, L, E, H, so that looks good. And then we can put Hannah in here. And now we can run it for that. Let's see what we get. Okay, we get A, H, A, N, N, A, H. Okay, so that looks good. All right, so now let's try taking this and putting it into LeetCode and submitting it to see if we pass all of the test cases. So let's submit that. And okay, looks good. So we have now successfully solved this problem here. All right, so that's it for this video. Now be sure to comment, like, subscribe, share, and check out the blog, and you can ask questions and share your solutions in the Discord chat, and you can donate on on Venmo now and a bunch of other places you can check out in the description below, including PayPal. Subscribe to our Patreon. You can also sponsor me on GitHub, and you can send us some crypto if you want. All right, so thanks for watching, and we'll see you in the next video.